There's another kind of test called the Breusch-Pagan test. You can read about it in your book that you can use to check for the homoscedasticity or the or similarity of variance without actually partitioning values of your explanatory variable. So this is the Breusch-Pagan, bleach-pecan, whatever you want to call it, test. Again, you can read about it in your textbook, but the first thing you're going to do is square the residuals. We're going to square our residual values. Okay. And so I've got those there. And then I'm going to run a linear model, do linear regression on these squared residuals versus the lot size values. Okay, so if you think about what that's going to do, you should see, I mean, if the variance is not changing across the lot size, then these squared residual values should sort of look uniform across there. Squared values are going to be non-negative, so it's going to turn those residual values up. They're going to make them all positive. If the variance in the residuals is going to is tending to increase as the lot size increases, then you should see sort of a linear trend line that's going to pitch up from left to right. It's going to have a positive slope. If, on the other hand, the variance in the residuals tends to decrease as lot size increases, then when you look at this linear model, you should see this regression line sort of pitch down. And let's do that. Let's plot the squared residuals versus lot size. Okay, so the idea here now is maybe I could drop that regression line on here for the squared residuals versus lot size. I want to know, is there statistical significant evidence to conclude that the slope of this line differs from 0? And so for that, I can just take a look at the summary of my Breusch-Pagan test, like this, and I want to look at either one of these two p-values. Remember, this p-value is testing to see if there's statistically significant evidence that the slope coefficient differs from 0, and it's not. And this f statistic down here, remember, an f is a square of a t, right? If I square this statistic, this negative 0.445, I get this f statistic with one numerator degree of freedom and 109 denominator degrees of freedom. Here's my p-value. So it's not low. It's 65, 66%. So there, yeah. So I could use that Breusch-Pagan test to it looks like it's indicating that there's not statistically significant evidence to conclude that the variance changes dramatically with as a function of the lot size.